So I welcome you all on this first class of our CCNP ENCORE. Let me first introduce myself. My name is Gaurav. I'll be taking you through all these CCNP ENCORE and NRC classes. Okay, and I'm having around 20 plus years of experience, all into networking domain. I've worked for enterprise domain as well as service provider and data center domain. And I've been taking trainings from last 5 to 6 years now. Okay, so the mode, and the methodology that I used to follow is, mostly I'll be doing a whiteboarding. Okay, and along with that, we'll be going through the hands-on lab practice that I'll be showing you myself as a demonstration, and you will be getting a chance to practice through networking's rack also, virtualized infrastructure. Right. I hope all of you are, uh, since you have enrolled in CCNP and core, so you are already aware about basic networking at least. But in case, anybody is very new to this one also, he or she is very well welcome to ask whatever questions you have, or there is something that you are not able to understand, you can definitely ask me questions within the class itself. Right. So I just take few minutes and open the curriculum. So this is our CCNP ENCORE curriculum, in which it has been divided into 5 different modules. Our first module, it talks about architecture, network architecture. There are different things. Before that, if I tell you a brief history about these Cisco certifications, in about 4 or 5 years back, we did not have this ENCORE certification. Earlier, it was like CCNP routing and a separate exam for CCNP switching, and then a couple of specialist exams also. But now what Cisco has done is, for each domain, may it be enterprise, may it be service provider, collaboration, security, or data center, what they have done is they have built a core module. In enterprise, it is known as ENCORE. In SP, it is known as SP core. Similarly, DevNet Dev core and DC core itself, wherein in this ENCORE or the core exam, they are touching all the technologies that belongs to that domain. Okay, it does not expect you to have an expert level knowledge, but yes, you should be aware about all these stuffs. Okay, as a intermediate level, you should have that knowledge. For example, if I talk about enterprise and core, it is talking about your enterprise network, which includes your routing as well as switching, wireless domain, SD-WAN, software-defined WAN, as well as software-defined access solution, right? And then some virtualization concepts. Along with that, these infrastructure details wherein we'll be covering our layer 2, layer 3 wireless and some IP services. Then network assurance. So what I mean to say is it is covering everything. In fact, security and automation is also there. But um, I mean, at an intermediate level, it will not go into deep level over here. If I show you something, for example, this, where we are talking about layer 3, right? Here it talks about the routing concepts, configure and verify OSPF and eBGP. It nowhere involves iBGP also, because that part Cisco has kept for a specialist exam. We have NRC, which is predominantly, it is only for your advanced routing infrastructure. It does not cover switching itself. NRC is purely advanced routing concept, wherein this all these EHRP, OSPF, BGP routing protocol, they are discussed in detail with hands-on practice also. Right? Anybody have any questions so far? Okay. All right. So, anyone of you who is new to networking world, or you all are, gone through CCNA level training? or certifications?
Hey, hi Gaurav. I'm new to this networking.
Okay, Monica. So is this your first class into
Yeah,
networking? You have any hands-on experience or what do you
no, I
call
don't have
practical
any
experience?
experience, and this is my first class.
Okay. Okay, no problem. I'll try to take care of that.
Okay, thank you.
Anybody else? Okay, no problem. I'll consider it yes. So let's start with our architecture stuff first. Let me open a whiteboard. Mm, Ashraf, you have any question?
Yes.
Yeah, please go ahead.
So I I did CCNA.
Mm-hmm,
Like I also wants to learn a lot of enterprise network.
mm-hmm.
That is the reason which I specially selected Encore
Okay.
because I currently work in a company,
Mm-hmm,
a retail-based company. So I do currently manage a lot of uh, enterprise level networks
mm-hmm.
like store network, office networks, warehouse
Mm-hmm.
networks,
All right.
etc.
All right.
But I'm not 100% assured of what I'm doing. Like I only do basic things, but we have vendors onboarded who do everything. But I just monitor and manage little things with that.
Mm-hmm,
So my goal to join this batch is to gain some knowledge to handle that. Like we 100% use Meraki, then
mm.
it's like FortiGate sometimes and Juniper sometimes.
Got
So
it.
I just
Got it. No, I understand. I mean, most of the guys in their initial days, what we have is we are doing some level one kind of engineer work where we are supposed to monitor the network using some tools, and then in
Mhm.
case there is any issue, we do a preliminary troubleshooting, raise some ticket or assign some ticket. So that's completely okay, Ashraf. I mean, definitely I can assure you that you'll be able to upskill yourself once you have gone through all this course. This is the correct one.
Okay, thank you.
All right. So let me first discuss some of the basic concepts. Like for example, change this. One is you must have heard this term routing and switching. Can anybody tell me what's the difference between these two? Anyone?
Routing sends packets from one network to another, but switching just forwards packets within the network.
Okay, we can say internetwork,
Yeah, internetwork, that is intranetwork.
intranetwork. Okay, anybody else?
No, switching can only do the part of frames. It will not handle the
Frames.
packets.
Okay. Anything else?
Switching can transfer data through MAC address, routing do through IP address.
Okay. IP address. Okay.
Switching does broadcast. Router does not allow broadcast.
Broadcast. It may not allow broadcast.
Multicast, I think. Router work on multicast.
Loop avoidance. What do you mean by loop avoidance, Kiran Raj? In this context?
Think spamming tree.
So in switching, we have spanning tree, right?
Yes.
Okay. Okay. So most of you are correct. I mean, that's how we classify different things into routing versus switching. So OSI model, you must have heard or you must have read in your networking study. We have divided our complete this network, what we say that the communication into different layers: physical layer, data link layer, right? And then network layer, session layer. Okay, so before session, we have what we call
Transport layer.
transport layer, correct? Transport layer, session layer, presentation,
Application layer.
and application layer. Correct. Similarly, we have our TCP/IP model also, which is more advanced or more concise version of this OSI model, wherein we have only 5 layers. Now, this routing, when we say that we are routing packets, it means that we are talking about layer 3 network. This is layer 3. This is L1 or layer 1. This is L2. Correct. So this is all logical. Right? We cannot see this layers. This is all logical terms. At data link layer, this is layer 2. We talks about our switching. So when we talk about switching at data link layer, this is carrying your frames. That's why you told me that within switching, we are carrying our frames. At layer 3, we are carrying our packets. Okay, from each layer to another layer, what we are doing is we are doing encapsulation. Right, we are encapsulating our data into different headers and segments, you can say. At transport layer, we call them as segments. For example, I from my laptop, I try to open a website. Okay, www.google.com. So what we are doing is I'm trying to reach out to a server which is lying in the Google data center and acting as a web server on port 80, and it is having this URL or DNS name. This DNS name will be resolved with some IP address, okay, with which I'm communicating on this particular port. Right? That's what we have. Now, this server will be sending me some data, some web page. That data, this is your actual data. This data, how it is presented in an HTTP format. Correct. And then, I mean, I'll not talk about session presentation because these are, I mean, combined together in the TCP/IP model. Then at transport layer, you are adding, let's say if you're having a TCP connection, so TCP header port 80, source port, destination port, all that information will be there in that header. Coming to the network layer, it will be encapsulated with an IP packet. This IP header will be having source IP, destination IP. Correct. When this comes to a data link layer, it will be encapsulated another, Ethernet header, which is having Ethernet source MAC, destination MAC, etc. All those details. And at a physical layer, it will be converted into your signals. If they are electrical signals or your optical signals, definitely it will be converted like that. So these layers are nothing but your encapsulations. As soon as your data is traversing from top layer to bottom layer, it is being encapsulated. On the other side, when it reaches to this computer, it will again start decapsulating that thing. It will remove these headers. So far, so good. Anybody have any questions? Okay. Now, again, we spoke about a couple of things more. When we say inter-network or intra-network, what does that mean?
Intra-network should have a local connection, like
Local connect what?
considered as an local area network.
Okay, local area network, you said.
It
What
might
do
be
we
an
mean by LAN?
VPN, physical connection between devices.
Physical connection between devices. Uh, any other person would like to clarify what do we mean by intra-network in a switching world?
Within a same subnet?
Exactly. So it is within a same subnet. Okay, subnet, I hope you all must be aware about. For example, if I consider this subnet 192.168.10.0, if I write /24, what does that mean? What will be the subnet mask?
255.255.255.0.
Everybody agrees?
Agree.
Yes.
Anybody who does not agree?
Agree.
Okay. Now, this is our subnet mask. If I say the valid IP address within this subnet, what will be the range?
192.168.10 dot till 254 we can get.
1 to
1 till
254.
254.
So these are valid IP that belongs to this subnet. Correct? Everybody agree?
Agree.
Okay. Now, how about this one? 192.168.10.0. What is this?
Network ID.
Okay. Or we can say this is subnet ID.
Okay.
Yeah, that also we
Right?
can say.
And how about the last one?
Broadcast ID.
Broadcast
This
ID.
subnet.
So this is
subnet.
broadcast ID for this subnet. Correct? So this IP, it is identifying this subnet itself, and this is the broadcast IP. If I send any request to this IP, that request will be sent to all the hosts that are there within this subnet. That's what we mean by broadcast ID. Correct? So if the two hosts that belongs to same subnet, that means they are intra-network. Correct? They'll be switching the traffic. We'll be switching the traffic between two hosts which are part of same subnet. We are not routing it. They can talk to each other at layer 2 level. Is this fine with everyone? Or in other words, we can also say that they are in same VLAN.
Yeah.
Right? Does that make sense? Anybody who disagree or have any confusion, please let me know. Monica, are you clear? Okay.
So in the subnet marks, can we take 192.168.10.255
In
slash
subnet mask,
24 is having 256 IP addresses, right?
correct.
So can we take in broadcast ID 255? No. Here the valid IP can we take in the place of 254, 255?
255 is our broadcast IP. We cannot assign this to any host. First IP and the last IP we cannot use. That's why they are not considered as valid IPs.
Okay.
Right? Okay. So I was telling that if two hosts that are part of same subnet, or in other words, they are part of same VLAN, they'll be switching your traffic at layer 2 only. They are not being routed. Correct? Now, if there is a host who belongs to this subnet, he wants to talk to, let's say, this subnet. Correct? Then the host himself knows that I need a router who can route my traffic to this destination subnet. So inter subnet is always routing. Do you guys agree?
Yep.
For example, this is your laptop 10.10. This is the IP that you have configured, right? Within our network configuration on your PC, in your Windows, you must have seen that there are few things: IP, mask, gateway. These three things you configure. IP and mask are mandatory. Gateway is optional. If let's say I have configured like this, and you want to communicate with the destination IP of 192.168.10.20, will he be able to communicate with this destination? Yes,
Yes,
no,
we can
maybe.
communicate.
Yes, we can
Yes.
communicate. How it will communicate?
These both are belongs to same subnet.
They both belongs to same subnet. So what does that mean? It's a layer 2 communication. Correct? It will be a layer 2 communication. Right? And in layer 2 communication, you exchange frames. Correct?
Yes.
Okay. So this one will need to create a frame. Let's say my data is ICMP, ping packet. On top of that, source MAC, destination MAC. These are the two main things in your Ethernet frame. Right?
Yes,
This will be your Ethernet frame.
Yeah.
You know your source MAC. I have some MAC over here. MAC address is of how many bits?
32 bits.
48 bits. IP address is 32 bits.
Yes.
Okay. This PCA and this is PCB. So does PCA knows the destination MAC?
No, it doesn't know.
He doesn't know. Then how will he create this frame?
It will request for
Broadcast.
Yeah.
It will be a broadcast, right? And that what kind of broadcast it will be?
ARP
Interline.
broadcast.
It will use ARP protocol, address resolution protocol, because this PC knows that I need to communicate with this IP, and this IP belongs to my subnet only. How PCA knows that my destination is within my subnet? Because of this IP and mask that I have configured. That's how he himself knows that. Correct? He does not know that I need to reach out to a router. He himself has decided that this destination is within my subnet, because This is the valid IP address range for my subnet. Internally, he is intelligent enough to do this subnetting and getting all those things. Now to get this MAC address, it will send an ARP request as a broadcast. He will respond him back with his own MAC address. Let's say destination MAC address, all Bs. That's how your frame will be created and it will be sent to your destination. So far, so good. Any questions?
Yeah, actually, I'm having one doubt here.
Yes, please.
Like the system will generate the ARP request to the switch towards
Correct.
switch. Yeah.
Okay.
If the switch has the so let's say if the switch is having the IP address like of that MAC address, so it will request back that IP or like that frame will be reversed.
Okay, you are saying this is your PC.
System.
It
will
is
request
connected to a switch.
Yeah.
And
will
switch
know
is
about
further
that PC.
connected to another
Yeah.
PC. Right? This is B, this is A. Now he has sent a request that who is 192.168.10.20. It has sent this request.
Yeah.
Now what's the question? It's a broadcast request basically.
Exactly. Yeah. So switch will be knowing about the system B. Like it will have the MAC address and IP address in its MAC address table.
Okay, in its MAC address table. Okay, let's first discuss what's there in the MAC address table. I have a port.
Yeah.
I have a MAC address table and I have a VLAN ID.
Yeah.
I don't have any IP address.
Okay. Okay.
Right?
So switch will not be Switch will not get any details about the IP address. It will just like MAC address.
Yeah, this is layer 2 switch.
Okay.
Right? It does not have the IP address details. I'm only storing that on port number 1, AA was learned. On port number 2, BB was learned. These are nothing but your MAC addresses.
Okay.
And they belongs to, let's say, VLAN 10.
Okay.
Right? I don't have any IP address information.
Yeah.
So what will happen is when this broadcast has been sent, the switch has received this broadcast in VLAN 10. It will send that broadcast to all the ports which are also in VLAN 10. For example, I was having a third port that was also configured in VLAN 10, connected to third PC. That broadcast will also be sent over here.
Okay.
Right?
So
Then only this B will respond you back that this IP address is possessed by me and this is my MAC address against this.
Okay.
Hello, sir.
Yeah. No.
Any question?
Hello, sir.
Yes. Myself,
Yes.
Rajit Rai. I have
Yes,
one
please.
question that if we assign the default gateway IP, then the message will be a broadcast message or unique.
No, we will come to that point. Okay. I'll come. I have deliberately not configured gateway in this PC.
Oh, okay.
Right?
Hello,
Anybody
sir,
have
I can.
Yeah, please.
Sir, it is happen in the data link layer. I'm right, sir. How to learn the MAC address? First know the MAC address, then go to the network layer.
Correct.
How it is possible? The first machine don't know the destination MAC address. First learn the MAC address, then go to the IP address. Then packet is complete. How it is possible, sir? How to know the MAC address, sir?
How to know the MAC address? It is using ARP to know the MAC address or to learn the MAC address of the destination. It is sending an ARP request, which is sent as a broadcast. Who is having the MAC address against this IP address? Then computer B is responding you back that my MAC address against this IP is this one. Now your laptop or your PCA knows that the MAC address against this IP is this one. It is maintaining that in its ARP table.
Switch or table?
No. This computer, this laptop.
This laptop don't know the MAC address of the second machine. First time, when it is bind the fail.
He does not know. That's why he sent this ARP broadcast request to know that MAC address.
Okay, sir.
Okay, he has said that, for example, we all are connected in this Zoom or WebEx room, right? Now,
Right,
I
sir.
don't know, I only know that, who all are we have?
Sir, I don't, in this moment, the layer 2, the machines don't know the MAC address, only know the IP address, sir.
Only know
I'm
that.
right, sir.
For example, if I take an example, for example, you are Siddharth, right?
Yes, sir.
So, Siddharth, for example, you joined by the name Siddharth only. I don't know your second name.
Siddhartha Shankar Biswas, sir.
No, I agree. But if I want to know, hey,
Oh,
is
sir.
anybody Siddharth there? I want to know his last name. What will happen is nobody else will respond. Only Siddharth will respond me back, Shankar Biswas.
Yes, sir.
Correct. Same thing is happening over here. PCA is sending a request. Is anybody there who is having this IP address 192.168.10.20? Please share your MAC address. And this is, since this is a broadcast message, everybody can listen to that, but only computer B will respond you back.
Okay, sir. Means the machine one send the whole packets, not the packets, complete the layer, whole 7 layers, then send it. Okay, I'm not right.
No, actually the frame it will contain source IP and destination IP. But only MAC
No,
will
no,
be
no.
FFF. So
Okay,
once you get
this ARP frame. Okay, since it is another Ethernet frame, I will have something like source MAC as AA, destination MAC as your all F, which is a broadcast MAC. Okay, that's why it will be sent to everybody.
no, I think it also contains IP address, no, in the frame,
No,
like source IP and destination.
within, not within the frame. Inside that, it will be having ARP packet.
Okay.
Okay, what kind of packet is this? Request packet.
Okay.
This becomes a payload for this Ethernet frame.
Okay, is it possible like we can capture the packets or capture
Yeah, we can.
we have in
Definitely we can. Yeah, I can show you. I can show you. In some time, I'll show you that.
Yeah, sure.
We can do a Warshak capture also. Does that answer your question, Siddharth? Okay.
So
yes.
basically, I think I got what Purushottam wanted to ask. It cannot have the layer 3 encapsulation on this because we are doing an inter-LAN routing. So it has to be an ARP packet, sorry, ARP frame with the outer address being just the layer 2 address, correct? It cannot be an IP packet because it has to go through a layer 2 switch anyways. So this
It's
ARP
only layer
frame,
2.
only layer 2, exactly. So it is not an IP packet, correct? Is that correct?
Ethernet frame will be having the IP address, no? Like it will contains about details about the IP address also.
I mean, this one, you are encapsulating the ARP request within that, but sir, can you confirm what is the source and destination IP in that ARP frame?
One moment. Let's
can
see
you
a Warshak capture.
Yeah.
It will be more clear.
Yeah, that's it.
Sir, only capture the frame, sir. Okay, sir.
Yeah, sure. No worry. Let's assume the same scenario. So switch by default, all these ports are in VLAN 1. Okay, so we need not to do anything over here. Let's see on this PC. Host name, let's say PC1. IP routing interface E0 by 0. Let me shut it down first. IP address 168.10.10. Okay, this is what I have configured. Just an interface. It is as of now shutdown status. Now PC2. IP address 10.20. Okay, nothing else. Now let's do one thing. On E0 by 0, let's capture the traffic. Okay, and PC1, if let's say I unshut this interface, okay, or I'll disable CDP also. If I unshut this interface on PC1, what has happened? It has first of all sent a gracious ARP, right? What is this gracious ARP?
So it's looking for a duplicate IP. Like
it is looking for a
sending,
duplicate IP. Can you see this sender IP, sender MAC, and
yeah.
target MAC is broadcast MAC, and target IP is also same as sender IP address. That's how it is looking for a duplicate IP. Correct? What has happened? I mean, what was the impact of sending this gracious ARP? This switch must have learnt MAC address for this E0 by 0 interface. Correct? Switch has learnt in its MAC table this one. Right? This one is tail entry because once we powered on this one and then I shut down this interface. We can clear this also. Clear MAC address table, dynamic interface E0 by 1. Still it is coming. Maybe, but yeah, I hope you understood this concept of gracious ARP. How your MAC is being learnt via your switch.
Yes.
Right?
Yeah.
Okay, let's move further then. Okay, from this PC, if I check show IP ARP, I don't have in my ARP table, I don't have entry for 20.10 or 10.20, sorry. Correct? If now you start sending a ping to this 10.20, correct?
Yeah.
So it has first sent this ARP request.
Okay.
Can you see this? Who has this?
20.
It is saying who has 10.20. What is this? This is your ARP request.
Yeah.
Correct?
So in that, yeah. So in that source IP and destination IP is there now. Like if you can check.
Correct. Yeah. So
Yeah.
definitely it is
Okay,
sending
inside the
source
ARP, it
IP,
is having the
destination
details.
IP.
Okay, okay.
But this is inside the payload of your frame.
Okay, now I get it. Yeah.
You got it?
Yeah, now I get it.
I was telling you that my Ethernet frame, which is having Ethernet header, inside that I am having ARP request payload. I don't have any IP header. See, over here, I don't have any IP header. This information, source MAC, source IP, sender IP, the target IP, this is there in the ARP request packet only.
Okay.
Got it? And
Yeah.
it is being sent to a broadcast address, all F.
Okay.
And then he should respond, because this interface is as of now admin down. So he has not responded, but it is sending it.
Okay, it will get the request back again. Like
Yeah,
this
he'll reply back.
address for this
You will
particular.
get, yeah, you will get, instead of this ARP request, it will be a response or reply message. Let's do that. I'll come back over here. If I unshut this interface. Okay. Now if you, gracious ARP has been sent. Okay, that has come over here also. If I check IP ARP, no, nothing. Ping, repeat, let's say 1. See now, it has sent a broadcast request.
Yeah.
PC1, and this has the reply from PC2. This is your reply packet. And another thing that you should notice over here is your reply packet is no more a broadcast. It is a one-to-one. Destination address is this one.
Okay.
Your reply frame, it is being sent directly to PC1, not to anybody else.
Okay, understood.
Clear?
Yeah, clear.
Okay.
So did the gratuitous ARP for 192.168.10.20 got auto-triggered after we sent the ping?
No. Before ping.
Did you actually manually generate a?
I just unshut.
You unshut it, right? Okay.
Yeah,
Yes.
when I unshut this one, it generated that gratuitous ARP.
Yeah, sounds good.
Right?
Thank you.
I think we have some different ARP requests also, no? Gracious ARP, reverse ARP, proxy ARP.
Yes, there are different things. Let's not go over there, otherwise we'll be derailed.
Okay.
Okay. So I hope so far you guys have understood, within same subnet, it is purely your Ethernet frame. I don't have any IP header over here. It does not have your IP header. This was your original payload ARP, which gets encapsulated in your Ethernet header, and this is your layer 1, L1, L2, and this was your kind of the original payload that is being encapsulated. So that's why we say this communication is happening at layer 2 only.
Hello.
Yes, please. Yes, that.
Sir, main things is we are set the IP address in the payload field, layer 2.
Correct.
It is the main things, no, sir?
Yeah.
Okay, sir.
Yeah.
Thank you, sir. Thank you, sir.
Okay. Now let's move to other part, that the same PC now wants to communicate. This is your source, PCA 192.168.10.10/24. See, we did not configure any gateway over here. In your PC also, PC2, PC1, IP route. I don't have any gateway. Default gateway is not set. Correct? And that's how you were able to communicate within your subnet or within your VLAN. Right? Now, if this is the same PC, he wants to communicate to another PC, which is having IP address, let's say 20.10 now. And I have not configured gateway. What will happen?
So ping will drop because it doesn't have
it will drop. Okay, let's assume we need a gateway. First of all, you guys agree?
Yeah, we need
this is inter subnet, so we need a gateway. Correct?
Yeah.
Okay. So gateway, let's say you configure 10.1. There should be a routing device in between. There should be a router in between who can route your packets between these two subnets. This is your 10.0 subnet. This is your 20.0 subnet. So the purpose of having a router, or we can also call it as a layer 3 device, is to route your packets between two different subnets. That's why this gateway will be required. Who is my gateway who can help me going to a different subnet? Make sense?
Yeah, got it.
Okay.
Yep.
Now, if we take the same scenario, let's first understand theory and then we'll see the practical. This is our router. Let us assume we have configured everything. This is having this IP with a gateway of 192.168.10.1. It is connected to another PC having IP 20.10/24 20.1. So this interface, let's assume this is 10.1 interface and this is 20.1 interface. This interface we have configured with an IP of 192.168.20.1. This interface E0/0 has been configured with 10.1. So far, so good. Any question?
No question from my side.
Okay. Now, will they be able to communicate now? PCA to PCB.
Yeah, they should, no.
Yes.
No, they should not be able to, because in the router
Why?
we should configure the IP route, right? Static route should be towards
IP route for what?
Like if it reaches a destination, the packet will reach a destination, like 10.1, and after that, that network has to connect to 20.1 via any routing protocol.
No,
Okay.
it's all connected.
Okay, let's park this question for our practical. We will see. Right? I'll clarify whether it will communicate or not. And let us assume that as of now they will communicate. Why they will communicate, we'll see in the practical when we'll do. Now, can anyone tell me that this PCA wants to send a ping packet to this destination 192.168.20.10? What will happen? The step-by-step sequence. Assume ARP table is empty.
Yeah, correct.
ARP is empty for everyone. Now tell me.
So as soon as we hit the 20.1, which is a different network, so it will start. So it will directly, so directly the frames will be towards this 10.1. Like gateway, it will go if it is a different network. It will not
Destination MAC will be R1's Ethernet MAC 0/0 MAC.
10.1. So it will not check for ARP table. Directly, it will initiate the packets to 10.1.
Okay, so
I think the fast machine learn the router port MAC address, I think.
Okay, let's try to construct that frame. My original payload is ICMP.
Yeah.
Okay. Then?
Yeah, source IP will be 10.10.
Source IP 10.10.
Destination will be 20.1. So 20.1.
Destination IP
20.10. Yeah.
20.10. Right.
And
This is my.
Yeah.
This is our IP packet. Right.
Correct.
This IP packet we need to encapsulate within a frame.
Yeah.
L2 frame. Source MAC. Destination MAC.
Yeah.
Okay. Now what will be our source MAC? Let us assume AA.
Correct. Okay.
Now the question is, what is destination MAC?
The R1 interface.
R1's Ethernet 0/0 MAC.
This one.
Yep.
No, it will be broadcast.
No, it will be.
Nope. Because it knows that is its gateway, it'll know to send it to that R1.
But we are pinging to 20.10, right? So it will be broadcast packet.
No, it will not check for the app table once it is different network. It will directly.
Okay, wait. Okay, so ideally this MAC address should be of this one.
Yeah.
But am I aware about what is the MAC address of R1 E0/0? I may not be aware because ARP is empty.
Okay. If it is empty, then it will look for the MAC.
Okay. So I'll send a ARP request for this IP. Please share the MAC address for this IP address. Correct? So then I'll get the MAC address of this one. See, guys, please try to understand. What happens is your Ethernet frame, when we talk about Ethernet frame, it cannot go beyond your subnet. And this is your one subnet. This frame, when it goes out of this subnet, it cannot go as it is. This packet can go out of this subnet.
That's it.
Okay, this is your packet.
L2 packet will be discarded, I guess, at R1.
Yes. Let me complete that. So this frame, which router A has created, PC A has created, this frame will reach at R1. R1 will check, okay, the destination MAC address is myself. R1 will decapsulate this and it will keep this green packet only. It will remove this Ethernet header because this Ethernet frame was destined to myself. I'll remove that. Okay, internal packet I will see. Source IP, destination IP, and ICMP. Now, since I am a router, I want to see the destination IP. Based upon that, I'll take a decision where this destination IP lies. Right? Okay, this destination IP lies within this subnet or within this domain, Ethernet domain. Okay.
Look for the routing table. Like, what is the next?
Yeah, he has already checked. He has already checked that this destination is within my connected subnet, connected interface subnet. Okay, so he knows, okay, it is connected to myself only. I need to send a frame out of this interface. If I want to send a frame, I will have to encapsulate that within a Ethernet frame. I need source MAC, destination MAC. Source MAC will be this interface MAC, E0/1. This interface would also have some MAC that I'll put it over here. What will be my destination MAC? Destination MAC is, again, I need to send a
broadcast, find that out
to get the MAC address of BBBB.
So
then I'll be able to create this frame.
Perfect. So before, as I don't know, as R1 didn't know a destination MAC for B, it would basically do an L2 broadcast separately, L2 R broadcast separately. Understand its, find out its MAC address, then update this particular frame and send it out, correct?
Yes, there will be two frames. One, I'll be sending an ARP request to get the MAC address of 20.10. Post that, I'll be sending this ICMP. That's why you must have seen sometimes when you send first packet, you get a drop, and then after that, you start getting response.
Got it.
But like initially, it will look for the routing table, right? Like
okay, I'll come to that point. Actually, the problem is, okay, your point is valid. Since R1 is a router, I need to check my routing table, routing information base, right? Within my routing table, how do I populate my routing table? either connected routes C
routes
or static routes or OSPF routes,
local routes.
EIGRP
ये
routes.
क्लास आज क्लास था और ये कितना बजे चालू हुआ पता भी नहीं चला, इसके लिए मैंने मैसेज किया
संदीप,
था।
hey Sandeep, please go on mute. Class चालू हो गया. Okay, so what I was telling is, in our routing table, we are populating this routing table from different sources. One of them is your connected subnet. Since the both E0 by 0 is having a connected subnet 192.168.10.0/24 connected via E0 by 0. Similarly, another routing entry for connected route only 20.0/24 E0 by 1. So I have these two entries within my routing table. So your point is valid. Yes, it will check its routing table. From there, it came to know this destination lies in this subnet, which is connected to myself. Okay, I need to send this data out of E0 by 1. So from E0 by 1, I need to send out the ARP broadcast request. Make sense?
Okay, now I get it. Yeah, it will be able to ping. Yeah, correct. Yeah.
Hello, sir. I just have one question.
Yes,
Sorry.
Ashraf.
I understood about routing table. Like, what about ARP table then?
ARP table is a separate table that I'm maintaining.
Now, usually what will happen, it will look for the RIB, and after that IP it will look in the
Then
ARP table.
in ARP table, we have MAC address first, right? Then we also have IP address.
No, wait. Let's see. What is the structure of our ARP table?
I think first MAC address.
Okay, I have a MAC address and have an IP, associated IP. Yeah. Correct? These two things I have.
Yes.
Right? So assume in R1 ARP table, I said this was empty. That's why I send a ARP request over here, E0 by 1, and got this MAC address. So in your ARP table, you stored this entry.
Yes.
Right? Post that, you were able to create this frame of your actual ICMP data.
Okay. Understood. Yes.
Understood? Okay. These ARP entries and your MAC entries within your switch, they have their default timer. After that, it will be automatically flushed out. If you are not getting any traffic, if it is not getting refreshed, it will be flushed out.
Yes.
Is this communication clear to everyone? We can see this quickly in our event also.
Sir, while doing live, okay, can we also already we have this topology, right? With one switch, two PCs. Can we just like refresh ARP as well, just to clear everything?
Sorry, I didn't get your point.
ARP entries as well in this switch.
No, switch
with
because
Wireshark.
this was layer 2. Okay.
This must have ARP table,
No,
right?
because this is layer 2. I won't have any
layer
ARP.
2. Layer 2.
This won't have any ARP.
Correct. Sorry.
Layer 2 will only have MAC address.
Okay.
No, initially I'm having one. So actually I'm having root one down. So after looking in the RIB routing table, that specific IP again it will look in the ARP table to form the L2.
Correct. Yeah. To form this L2 frame, I need to know the destination MAC. And this destination MAC from where I will read, I'll read from my ARP table.
Yeah. So actually I'm having one more doubt here. Like it will look for the FCS errors also, right? Like FCS. If it is corrupted, it will be discarded at the initial point.
FCS will come at layer 1. Okay, frame check sequence or all. I mean, FCS will come at when you receive some frame, whether it is having some errors or not.
Yeah.
So that's fine. I mean, that all operation are by default. That will be there. There is no logic into that. Definitely, that will be a part.
Okay, that will be a part.
Yeah.
Okay. But it is important, like if it is packet is being discarded, so we can check the FCS like counters.
Show IPR. If I show you on this switch, since it's a pure layer 2, I don't have any ARP entries over here. ARP entries you will only see at your layer 3 level. Right? Shall I remove and put a router instead of this switch?
Yep.
Okay. I'll have to stop this.
I'm having one more doubt. Like, what is the difference between CRC errors and FCS errors?
CRCR cyclic redundancy check.
Okay.
FCS is, CRCR layer 1. FCS is about your, while framing kind of error. There are different frames that you can create. At layer 2, it's not only Ethernet. We can have HDLC encapsulation, PPP encapsulation. So FCS covers all that.
Okay.
At a high level, you can say one is about.
Both are related to L1 layer issues only. Right?
FCS will be layer 2.
Okay, layer 2, and it will check for the layer 1, I guess.
Layer 1 will be your CRC.
Okay, CRC, yeah.
This is routed. If I connect this over here. On PC2 also we have IP address configured. PC2 IP, let's change. This we want now 20.10, huh? 20.10. Okay, on R3 on this router. Interface E0 by 0. I shall configure IP address 192.168.10.1. Okay, now before sending anything, if I check show IP ARP, I have only this one 10.10, right? PC2 IP ARP, I have only this one. I don't have the MAC address of router, right? If I check at router level, show IP ARP, I have only my local interface MAC address. Okay, or ARP entries. Why is it so?
Sorry, I didn't get you.
No part of the answer right now.
All the devices are in shutdown mode, right?
All the interfaces are shut down, right?
Is it so? No, they are up.
No.
No direct answer is still now.
They are up. First thing, what we are missing is we have not yet configured a gateway. So let's configure that IP default gateway 192.168.10.1. Same thing on PC2 also. 192.168.20.1. Okay. IP ARP. I don't have that ARP entry. Is my Warshak running? Yes, it's still running. Okay. From PC1, if I try to send a packet 20.10, this Wireshark is not running, I guess.
And sir, these days, even without PC initiating a traffic, the connected devices have a way to learn about each other's MAC, right? Or is it mandatory that a ping has to be sent from PC1 for R3
No,
to?
it's not mandatory. There should be some mechanism by which you will learn. For example, if I'm seeing the Wireshark on this interface, E0 by 0. Let's say on PC1 interface E0 by 0, if I shut this interface, okay, and I say a no shut. So if no shut, it sends a gracious R.
Right.
Correct? This gracious R would have been received by R3.
Oh yeah.
So now R3 would have an ARP entry for this one.
Right.
Right? Now ARP table of R3 is complete. If I check at PC1, this should also be complete. I don't have, okay. R3 has not sent any request or response back to PC1. Similarly, PC2 also, IPR, it does have. Okay, because that gracious ARP which PC1 has sent, probably it has learned because of some other protocol. But this ARP entry, once it is complete, then it will be able to create your frame. Okay,
but
now if I
did we did trigger that by doing a manual shut and no shut, right? Do we always have to trigger such things, or
no, it's not like that. It's not
okay?
Like that. Okay, if
As soon as it comes online, it will connect.
If
It will start
let's
sending
say it
that.
is not there, if I assume my ARP table does not have this entry.
Okay.
If let's say your ARP table is empty, what will happen? The first packet will drop, that's it. Not more than that. Next packet it will learn automatically. If I let's say in PC1, I don't have the MAC address of R1 Ethernet E0 by 0. Right? This router E0 by 0 I don't have. What will happen if I try to ping this? Repeat 1. It got dropped. Correct? But if you check ARP, you have learned the ARP.
Got it.
Right? Why it has learned this one also? Okay, so against this also it is showing the same map of this one, your gateway.
Yeah.
Right, maybe the proxy ARP is enabled over here. IP interface either by 0. Is disabled.
Can we just send
the
a packet
IP address on Ethernet 0/1 is configured as 10.1, sir. Can we check interface Ethernet 0/1?
E0 by 0 is 10 more.
Okay.
And E0 by 1 is 21 more. Okay, you got this entry via this ping. Now you should be able to communicate with this one. Repeat 1. Why again? We configured a gateway over here on PC2 also. You know.
We'll
Now
try
it is
to,
fine.
yeah.
Now it is fine. Yeah, now it is fine. You know. Now it is reachable. Actually, on PC2 somehow my IP routing was not disabled. I disabled the IP routing. I just put it as a gateway to emulate this as a normal computer. Just a gateway. I don't have any other routing information. Right. So in this ping packet, which 10.1 is sending to 20.1, if you see this was your original packet, ICMP ping, this is getting encapsulated in an IP header. Now you have layer 3 communication, wherein you have a source address, destination address, and other things. Correct? And then this original, the packet is getting encapsulated in your Ethernet frame, wherein your source MAC 10.0.0.0 and the destination MAC 30.0.0. So who is 30.0.0? It should be your show interface E0/0 input burnt in address. So this is your E0/0 of your router. This 30:00. Correct? So this is the same thing what we discussed in our theory also. Anybody have any question? Okay. So hope the differentiation what we were trying to discuss between switching and routing is now clear to everyone. That switching, it is within your same subnet. It won't have any IP header into that. Routing, it is inter subnet where we have a IP header also. Right? Ethernet frame, IP packet. Hope this is clear with everyone. Okay. Now moving further to some of the switching architecture. So within our campus network, okay, I'm as of now I'm talking about our LAN, local area network. So LAN is within a small geographical domain, maybe few hundred meters, right? That is that becomes a constraint or within one location only. I will have my local area network. So if let's say I have a computer or I have a switch basically, and the switch is connected to different devices, let's say some computers, some IP phones, some servers, some wireless access points, some printers, network printers, right? And then it is connected to a router, and that router is providing you internet access. So this kind of network, it's applicable or can be used within a smaller network, right? This switch, maybe if it is a non-modular switch, it will maybe around 24 port switch or 48 port switch within your small office or home network. This is okay. Correct. This is sometimes it's also known as a flat network. Correct. This if your number of ports demand is increasing, what you will do in this kind of network?
We'll connect another switch and we'll connect.
You will connect another switch, right? You will connect another switch somehow, and you will interconnect these switches together also, and you will terminate your endpoints onto this second switch. Correct. Again, this is a kind of your flat network, which may be having one, a layer 2 level, and then this is acting as a layer 3, from where you are able to access your any other site or your towards your internet. This is again your flat network. Another possibility could be if it is a modular switch, you can have different line cards into the same switch. You can add another line card, right? Now, if I talk about a hierarchical kind of network, wherein I may have a 2-tier architecture or a 3-tier architecture. If I talk about a 2-tier architecture, I can have several access switches. Access switch 1, access switch 2, access switch 3. Okay, and then I can have a layer of core or aggregation switches. For redundancy purpose, let's connect them with dual links. And on these access switches, you are connecting your endpoints. These endpoints can be anything: your computers, your IP phones, printers, servers, etc. Right? From this core or aggregation switch, you may have connectivity to your router, which is connecting towards your WAN area network, wide area network, or your internet. So this kind of campus design is known as your hierarchical network. Can you tell me some of the advantages and disadvantages between these two, flat versus hierarchical?
Cost. First one is cost.
Okay. Which one is more, which one is less?
Will be having less
small
cost.
bucket, yeah, small bucket is flat network.
Cost is less over here, more over here. Yeah, somebody was telling another factor.
Yeah, hierarchical redundancy is there, but we don't have any redundancy in the flat network.
Correct. Very good point. So redundancy is, we don't have anything. We have this in hierarchical.
Failover recovery.
Failover. Failover or redundancy, I mean, we may not have in this one.
Yeah.
Okay. Or it is less, it is more over here. Any other thing? Easy to manage.
Yes.
Scalability.
Easy to manage. It is more, it is less. Scalability.
Scalability is
another
poor in flat,
yeah.
better in.
It is better in our hierarchical network. Right? So on these few of these bases, we decide what we need to go with. But I hope this part is clear now. What is we call as a flat network? It is more applicable in your small office or home office kind of network. And this is, I mean, when we are designing or when we are planning for our campus network, that's how we will look forward. So if we think practically about this hierarchical network, let's say I have a building. We have a 4-floor building, which needs to be, connected together all the floors in a network. What we can do is, let's say on the ground floor, you put your server room. Inside that, you connected your, provision your core switches, 1 and 2. Okay, and it may happen on this ground floor itself. You have some staff which is sitting, which may require some network connectivity. So at ground floor also, you will connect an access switch, 1 or 2, depending upon the port requirement. Then from this core switches, from ground floor to first floor, and similarly to second floor, third floor, you will take the cabling and you will connect your respective access switches. Correct? Any question? So far, so good?
This is an hierarchical network, right?
This is this is hierarchical network. This is hierarchical network. Now, if this was first building, okay, building 1. If tomorrow, let's say your company size is increasing, you have bought another building within the same campus. What will happen? The same 4-floor building, for example. You may have another pair of Core switch is over here. Again, access switch, access switch. You follow the same design. How will you interconnect them?
It's stack, not stack.
Okay, it may happen that you put another layer of hierarchy. This was 2-tier. This was tier 1. This was tier 2. Okay, rather than calling them as core switches, make them as aggregation.
Yeah.
And connect them to a core switch. So this becomes our 3-tier hierarchy. This is access is tier 1, ag becomes tier 2, this becomes tier 3, and this will be connected to the router. This is the practical thing how we do in the production network. Any question? Okay. So as you said, scalability is better in case of hierarchical network. So you could easily enhance or increase the port capacity within your network because this hierarchy you created initially itself. You could easily arrange another building. If let's say third building also comes tomorrow, that can also be connected to your core switches within the same hierarchical model, ag switches, aggregation switches, access switches. Isn't it? It is easily scalable. But definitely, I mean, since it is more scalable, more redundancy, more backup links I do have, that will have additional cost. Because these core switches and aggregation switches, these are nothing but they are only providing you transport. If you want, you can connect your servers here also, but as of now, they are only providing you connectivity between two access switches or from access towards your core network. That's why it's an additional cost it is adding. Right? Any question about this layer 2 or tier 2 versus tier 3? Okay. Let's take another design. Assume this is our access 1, access 2. It is connected to, let's say, a distribution switch. Distribution switch or aggregation switch, one and the same thing. In campus networks, sometimes it is also the aggregation switch is also known as distribution switches. Okay, let's say that's how you have connected. This is one of your server S1. This is S2. This S1 is, let's say, IP this 10.10. This is also in same subnet. So if we are in same subnet, we will talk to each other at layer 2 level. Yes or no?
Yep.
Right. So within our switches, I'll have to span, I mean, this, let's say this is in VLAN 10. So here also there is a VLAN 10. They both wants to talk to at layer 2. So I need to trunk this VLAN over here. Since access 1, access 2, they don't have any direct connectivity. Okay, I'm communicating via distribution switch only. If I want to send any traffic from access 1 to access 2 or vice versa, it has to go from one layer above. What does that mean? That means I have to make them these links as layer 2 trunks. What is access port, what is trunk port, I'll cover. But layer 2 means, I mean, trunk or access, it means it's a pure layer 2 link. I should be able to send my layer 2 broadcast from here till here. Correct? Okay.
Sir, I have a question.
Yes, Ashraf.
So as you said, these are the distribution switches, and the other layer is core switches. So just to align my understanding, so distribution switches will be able to aggregate links via ports, which will have an active passive link or the Ethernet bridge between two ports, something like that.
Say again, please. What's the question?
So what is the difference between an aggregation and aggregation switch versus the core switch? Like the major
There is no
difference.
No, there is no difference. This is just a nomenclature. It is nowhere configured. You won't configure something as a aggregation. No. I mean, within your Cisco CLI, you won't say anything that this is aggregation, this is core. No. It is a logical layering of your network for your architecture. Okay. You are calling it as distribution. Tomorrow you can call it also as an aggregation. In a two-tier architecture, you will call it as core also. Doesn't matter. Your access can be connected to a core. Wait for some time. I hope I'll be able to clarify. I understand what's the doubt in your mind. That's from configuration perspective, whom shall I call as distribution? Whom shall I call as core? What should I configure as core? Or what all things should I configure at distribution?
Include a stack or how we aggregate a port.
I'll come to that.
Something like that. Yes.
Yeah, I'll come to.
Hello, sir. One question, sir.
Yes,
hello. Sir, can I put the server in the distributed layer switch?
You can. Nobody is stopping you. No, you can. Okay, you can put. No worries. Okay, right. The thing what I wanted to make you understand is this is a two-tier architecture. If I take, okay, so if S1 and S2 they both are in same VLAN or same broadcast domain, I will have to extend this layer 2 broadcast domain among all the switches. Does that make sense to everyone?
How do I make it a layer 2 link, sir? Is that what you meant by trunk? Trunk, okay.
Yeah, trunk. I'll configure this as a trunk.
Got it.
Basically, the purpose is if S1 does not know the MAC address of this one, he will send a broadcast R.
Right. So
R should reach at layer 2 level till over here.
Till here, okay.
Okay, that should reach from either it will go out via this link or it will go out via this link. This distribution switch should be able to send it back or broadcast it back toward these links. And since it is an ARP request, you already know that it does not have any IP header. It is only having an Ethernet header. So it should have been sent on to all these layer 2 links. On all these layer 2 links, my VLAN 10 should be permitted. Does it make sense now?
Yes.
That's what I mean by this all should be in a layer 2 domain or layer 2 broadcast domain.
Okay, great.
Correct?
Yes.
Okay. Now, if I want to have another access switch, S3, same broadcast domain. L2? Yes, no?
Yes.
You need another access 4. S4, same broadcast domain. L2. L2. Now, assume that this access switch, each access switch is 24 port. 24 port. 24 port. 24 port. S1 sends a broadcast ARP request for this one. Let's say 10.20. Can you see this broadcast is going everywhere? Nobody is stopping you, isn't it?
Correct.
So in layer 2, actually, controlling this broadcast is a very tedious thing. There are methods to control that, but this is very dangerous. Because why it is dangerous is in your Ethernet frame, you don't have any TTL field, time to live. I don't have. That frame will not die itself because I don't have any TTL. If there is any loop, it will keep on roaming from one place to another place. And unnecessary, there will be a broadcast storm kind of traffic. At the same time, in the IP header, I have a TTL field, time to live. If I go from one hop to another hop, my TTL field gets decremented by 1. And once TTL reaches 0, this IP packet automatically discarded. It vanishes. Okay, so within this, layer 2 domain, we always try to confine my layer 2 domain. I cannot. Technically, I can extend my layer 2 domain unendingly, but that will definitely it will create a problem. So broadcast which S1 has sent, these access switch, access1, it will have to create, if it is a 24 port, 24 plus 2 uplink. Okay, so leaving this port, so 23 downlink, if I assume every port is in VLAN 10. So 23 downlink port and 2 uplink ports, 23 plus 2, 25 copies I'll have to create. This access switch will have to create 25 copies of the same broadcast packet, and we'll have to send it on all the ports. And same operation will have to do, every switch will have to do. They'll replicate that packet or the frame, replicate that frame across all the ports which are in VLAN 10. Any question? Okay.
Hello, sir.
Yes, Siddharth.
TTL for time to live. Sir, which one best for the and which number is the best for 225 or 64? The time to live. TTL field value.
Best means?
Best means time to live. How many times to leave the one destination to another destination? Right.
You are not going to configure TTL. It is by default.
It is automatically, no, sir?
Automatically.
We cannot manipulate it, no?
No, you are not going to manipulate this. For example, if I show you over here, this is your IP header. In this IP header, can you see TTL? This time to live 255. You didn't set that. By default, it was 255.
Maximum 255, no?
Maximum 255. Yeah, maximum 255. Okay. It's a 8-bit number, 8-bit field.
Yes, sir.
Right? Maximum it is 255. At each hop, it is getting decremented. Okay. Now, another thing. Distribution 1, distribution 2, access 1, access 2. If I connect like this, and S1 sends a broadcast packet. Access, what it will do is it will send one copy over here, another copy over here. Do you guys agree?
No.
Yep. Yep. Who does not agree?
I think it will use the STP, one portal block. It will use one.
Yeah. Ideally, I mean, I'm coming to that point. It will block. Why it will block is because otherwise what will happen is if I'm sending it both ways, this distribution is again sending it over here, and this distribution 2 may again send it over here. Okay, and it can come back also. It will keep on. I mean, this is a kind of loop that you can see. This network between D1, D2, and access 1. This is a loop. And since within your layer 2, you do not have any TTL also, to avoid this, there will be a spanning tree protocol. What it will do is, it will block one of the link. Okay, it will block one of the link. Which one it will block, we'll study when we'll do the spanning tree protocol. Correct? Another thing is, how can we avoid this layer 2 stuff? So, okay, I'll create another diagram. D1, D2, A1, A2. Source 1, source 2. If I say that VLAN 10 is only at A1, VLAN 10 is not there at A2, I'll make this as my layer 3 gateway. A1, access 1 as my layer 3 gateway. Now, these links are no more a layer 2 link. These are layer 3. Is there any problem of broadcast now? What do you guys think? No, Dinesh, I could not hear you.
No, the A1 will drop the broadcast.
So A1 will not send the broadcast beyond
Yeah.
this one, because this is now your layer 3 gateway. Correct? So that
Yes.
looping STP, layer 2 broadcast from, okay, all those problems are gone away now. But another challenge over here is you cannot extend your layer 2 domain from one switch to another switch. This becomes the boundary of your VLAN, isn't it?
Yes.
That's where VXLAN comes in, right?
Yeah, that we'll study later. Okay. So in this, I mean, this kind of architecture is known as your routed access. Herein, you are bringing your layer 3 at your access layer itself. Right?
So to go back to your previous question, it will still, the diagram that you drew above this, where we had L2 connections, it will still, that access was still sending it to both the distributions. Only the other side from the D2 to A1 was the only thing that got blocked, correct? Through STP.
It could be D2 to A1. It could be this one.
Anyone.
It depends. I mean, when we will study STP, then we'll come to know which one it will block and why and how to influence that. But one of the link will be blocked to avoid this loop.
Sounds good.
Since this became a loop, you don't want that. You will block one of the link, or STP will block one of the link. It can be any link.
Got it.
So in this routed access layer, your layer 3 starts from access itself. So this becomes your layer 3 domain. This becomes your layer 2. Otherwise, in
So
this
are you
one,
marking something? I couldn't see where you're drawing.
No, I
If you're writing, you have to see.
was just showing this one. So
You're not able to see.
Yes, yeah.
You're not able to see what you're
screen
writing.
sharing is paused. I think I pressed something. It says screen sharing is paused. Okay, resume.
Now able to see.
Okay, sorry. So I was saying, in this routed access topology, okay, my layer 3 starts from this layer itself. Below that, I have all my layer 2. First that, I have my layer 3 domain. Right? Similarly, on this one, this all is your layer 2. You are extending your layer 2 till your access switch. That's the difference between these two topologies. Sometimes it is also known as routed access layer, or it is switched access layer. Correct? But
We would need. Sorry, go ahead.
But the pros and cons is you cannot extend your layer 2 within different switches in this routed access topology. We have means to do that, but will not go there today. Right? Benefit is we are able to limit our broadcast. Yes, you were asking something.
Exactly. No, I was going to state the same point. Why would we still prefer the switched access? Is only when we want to extend it across different access switches.
Across different.
Yeah, VLAN across different. Yeah. Makes sense.
Okay. So we have seen this two-tier architecture. Tier 1 is access and tier 2 maybe core or aggregation together. This is two-tier architecture. It is also sometimes known as collapsed core. Okay, wherein your core and aggregation are together. Same device acting as core and aggregation. Okay, now let's discuss that two-tier architecture. I have my let's say access layer over here, and distribution or core, whatever you want to say, this is second layer. Okay, on top of that, I have my router, which is connected to internet. So this is my layer 3 link, layer 3. Assume this is also layer 3. I have this PC. This is layer 2. Layer 2 means trunk, right? So if I assume this PC is having IP 10.10, where will be the gateway of this one? This is access port in VLAN 10. Where shall I configure the gateway for this PC?
Access.
The R1 port.
Okay, it could be at R1, but if I'm assuming this is a collapsed core design two-tier, okay, I cannot have it at R1 because this is layer 3. I'll have to configure that layer 2, layer 3 boundary over here. This is layer 2, this is layer 3. So let us configure a VLAN 10 SVI with IP address 192.168.10. Let us assume this is 10.2, 24 over here. Similarly, on D2 also I can configure interface VLAN 10 as layer 3 IP address 192.168.10.3.24. Does that make sense?
Yeah.
Anybody who's not clear about this architecture or scenario?
Can you explain one more time, sir?
Okay. I'm saying this is my PC, which is having IP address 10.10/24, sorry. Okay. This is pure layer 2 switch. This is layer 2 link, D1 to A1 and D2 to A1. And on D1 and D2, I have configured my layer 3 SVI interface VLAN 10 with an IP address 10.2/24. And on D2 also, I configure 10.3/24. On this PC, I can configure a gateway. Let's say I configured 10.2. What will happen if I want to send any traffic which does not belong to my subnet? I will definitely be sending that traffic to this default gateway, which is D1. Let's say I want to reach out to internet. I'll be sending all that traffic to D1, and D1 will decide where he needs to send. So far, so good?
Yeah, understood, sir.
Yeah, any question?
Okay, you have two gateways for the same VLAN. So how are you gonna put the routing for it for this VLAN for L3 to go to the routing? I mean, because if
packets can go till default gateway, but from default gateway, how it will be routed towards outside the network?
Okay, let's say between D1, D2, and R1, I'm using OSPF.
Okay.
Okay, it's pure layer 3. Somehow you will be able to send that.
So there's a routing protocol which is running.
There is a routing protocol, assume. Yeah.
Then that's fine. Yeah.
Okay. Now, your question was there are two gateways, 10.2, 10.3. As of now, within my PC, I have configured 10.2. If I want to use both of them in an active standby manner, I can configure HSRP or VRRP, first hop redundancy gateway.
yeah, that's
right? That we will configure. I was not going over there because I just wanted to cover or make you understand how this topology is going to work.
Noted.
Correct. So this is our two-tier architecture. Collapsed core. Okay. So what we did, this second layer, or the first layer is purely layer 2. In the collapsed core, the second layer, which is, you can call it as distribution layer, you can call it as aggregation layer, you can call it as core layer. It is acting as a boundary between your layer 3 domain and your layer 2 domain. So that is the main purpose of your aggregation domain. Basically, this is the purpose of your aggregation domain. If I extend this topology into 3-tier architecture, access, okay, let's take core switch as well. These are layer 3. Layer 3 means you are running any protocol, assume OSPF. This is layer 3. This is layer 2. So now what is happening is router what is happening at access layer, it is purely layer 2. I'm just terminating or connecting my endpoints, servers, PCs, laptop, IP phones, printers over here. There may be certain devices which are needed by many such people. So for example, there is a web server. So that you will connect at your aggregation layer. There may be a firewall. There may be a load balancer. So all those things you will connect at your aggregation layer. Because aggregation layer can provide you layer 2 connectivity as well as layer 3 connectivity. Maybe 5 or 10 minutes more, anything.
They're not. You mentioned about HSRP, VRRP only when we are going to use them as an active standby, but I can still use a default gateway to D1 and D2, right?
Yeah, definitely. D1, D2 will remain your gateway. But the benefit of HSRP or VRRP will be you can have a redundant gateway. Okay. This is, they are nothing but your FHRP. FHRP is first hop redundancy protocol. Okay, we will study that.
But if from PC1 I can create a default gateway,
you can configure the individual also.
Individual ones, yeah.
Yeah, nobody is stopping you. You can configure.
Okay, sounds good.
Okay, so from yeah, go ahead.
The VRRP will give us a virtual IP, so that will map to both IPs.
Yeah, exactly. I mean, when we will study this FHRP, I'll clarify all those concepts. But here, the main thing that I want to make you understand is these three different layers: core, aggregation, and access. See the difference of their function. Your access is purely layer 2. I can have a layer 3 access also. That is, again, this one, your routed access design. Okay. Aggregation is normally, putting a boundary to your layer 3 domain and layer 2 domain. Core is, if we have 3-tier architecture, core is purely layer 3. I don't have any layer 2 over here. I think somebody was looking for this differentiation between these three functions. I hope this is clear now.
Even in the collapsed core, these web servers and load balancers will be on the collapsed core, the distribution switch, correct?
Mostly it will be on distribution switch, yes.
Yeah.
Okay. Collapsed core is nothing but, the same
when you include those
acting
together,
as core and aggregation together.
Core and aggregation together, yeah.
Depending upon the scale or how many ports you require, you may have collapsed core or a 2-tier design, or you may have a 3-tier design.
Perfect.
Right. Anybody have any questions? Is this part clear? Core versus aggregation versus access. Layer 2 versus layer 3, boundary, how we are creating. Anybody have any question? Okay. There is another kind of design. If let's say 2-tier architecture, again, D1, D2, access 1, access 2. Assume the link between D1 and D2 is layer 3. This is L2, this is L2, L2, L2. Do you see any loop over here?
No.
Yes, sir.
There is a loop.
Because packets are still forwarded via IP address.
No. Loop is within the, I'm talking about within a VLAN or within a broadcast domain.
Okay.
Let's say on access switch 1, we have VLAN 10. Here also I have VLAN 10. I don't have any loop within a broadcast domain. Within a VLAN, I do not have any loop. So this will also be in a forwarding state. This will also be in a forwarding state. Again, forwarding. Do you see any loop? Anybody? Please see it carefully.
Yes, correct. This one.
A1, D1, L2.
Everything is L2. All the links except this green link, all are L2. Do you see any loop?
Yeah, there is a loop between A1 to D1 to L2 and D2 to A2 to L2.
Yes, there is a loop. How?
Yeah.
Yeah. From L3 to 22.
Again back.
Yeah.
Yep.
Okay. So there will be an STP instance who will block one of the port. Correct? If I make this some change over here, if I, let's say, create it like this, this is again L3, L2, all are L2, huh? Red ones are L2. This is VLAN 10. I have VLAN 20 over here. I don't have any VLAN 10. Now, is there any loop?
No, there's no loop. No.
Now we do not have any loop.
Yes.
Correct? If I can have distinguished or separate VLANs on each access switch, I'll not have any loop. Okay. Routed access design, I've already told you.
But that is not serving the purpose, right? Like if I want to extend it.
It depends. Okay. What's your purpose? If you do not have that purpose of extending your VLAN, you are able to accommodate your devices on a same switch for one VLAN. It depends.
Right.
I mean, depending on your purpose.
Okay.
Okay. I'm just telling you to think about the different topologies and their challenges. Okay, another question. As per your experience or your understanding, what is easier to troubleshoot a layer 3 scenario or a layer 2?
L3.
L3. Anybody else having a same or different opinion? Okay, never mind. So when we were discussing this routed access design, so another benefit of this one is it's easier to troubleshoot because everything is now there. Layer 2 domain has been confined over here. Sometimes it is difficult to troubleshoot your layer 2 domain.
Sir, your voice is cutting in and out. I don't know if others also feel the same way.
Yeah, I do.
Is it better now?
I think so, sir.
Yeah, it's good now.
Maybe, don't know if there is any network issue. I'm actually sitting at the same place.
No, this is good now. It's good now.
Okay. Okay, fine. So I was telling you another benefit of our routed access design is it's easier to troubleshoot than your switched access design. Okay. Now, FHRP or HSRP, what we were discussing is why we use HSRP or VRRP is when I have redundant gateway. They both can act as my gateway, or if I create an access switch over here, A2, this D1 and D2, they both have SVI interface created. They both can act as a gateway for my server. Okay, I want to use both of them. That's where you can configure them in a HSRP group together. One of them will become a primary. If this primary goes down, automatically the secondary one will become your primary. Correct. Another design could be you can club these two together virtually. Physically, they are two different distribution switches, but virtually I can connect them or logically for my A1, they will appear as single. I can go away from this hassle of HSRP configuring two different switches. One of them will act as primary, another one secondary, and then switch over. What I can do is I can configure them in a VSS, virtual switching system, where two switches, physically they are separate. They both can act as a single switch. For A1, it will appear as a single switch. Although these are two links, they'll be bundled. Right? For A1, it will appear that it is connected to single switch, not to two different switches. In this scenario, you will not need any HSRP. Only one VLAN 10 will be created, which is having one IP. Any question? This is VSS. VSS in Cisco terminology, this is virtual switching system. There are specialized switches or some special products who support this one. Your 6500, 4500, and probably 9400, 9500, they support that. This one, I'm not sure, but yeah, these two 6800 switches, they support that. Any questions? There is another kind of virtualization which is known as switch stacking. 3 different or 4 different physical switches, they can be configured as a stack. They'll be connected via a special cable that is known as stack-wise cable. Okay, this is your stack-wise cable. Why we do so is to increase the port capacity and single management. Anybody have any question?
No
VSS,
redundancy though,
D1
right?
to D2 connected normally. In VSS, they'll be connected via a virtual switching link, VSL. Okay, that's how they will sync their MAC table. In stack, they need a stack-wise cable, a separate cable, which is almost 1 meter or 2 meter maximum. It's not more than that. So these stack switches, they must be within a single rack because the stack cable is not very long. In VSS, yes, they can be into 2 different racks, or maybe on 2 different floors also. Okay, this will be an Ethernet cable that will be connected. Any
Is
question?
this VSS same as MLAG, sir?
Okay, so MLAG or MCLAG, this stands for multi-chassis link aggregation. So for A1, one link is going to D1, another link is going to D2. Still, you are able to bundle them together. This is again MLAG. This is MLAG.
Okay.
Okay, normally between switch 1, switch 2, let's say I have a 1 gig link. Okay, I have another cable, gig 0 by 1, gig 0 by 2. Sorry, gig 0 by 1. Now, if they are individually up, your STP will block one of the port. And you are able to use only 1 gig link. You want to use both to avoid that STP to block one of the link, you can bundle them together. This is link aggregation. Okay, that is the purpose of link aggregation, to avoid STP and to increase the capacity of links between 2 switches. They both can be used at the same time.
Got it.
Okay, you will be able to load balance across these 2 interfaces. This is the purpose of link aggregation. I can have more, 3, 4, 5. There is certain limit, I think 8 or 16, depending upon your product. how many links you can bundle together at the same time. This is a basic kind of link aggregation. But if these links are going to two different chassis and still I want to bundle them together, that is your MLAG.
Sounds good.
Anybody have any question?
One more, sir.
Protocol. Yes,
Go ahead.
Go ahead.
Yes, sir, whatever protocol you teach us, so will that be also replicated in other devices such as other brand devices, Juniper,
Yeah, mostly.
Cisco, Meraki?
Yeah, mostly
Oh.
these are open standard kind of protocol, but some of these terms may be Cisco specific. For example, XSRP. This is Cisco proprietary. VRRP is open standard.
Okay. So
Okay, some of the protocols will be proprietary also.
So there will be an alternate for every protocol in other
Mostly,
brand.
yeah, mostly it is there. Mostly
Okay,
it is there.
understood. Okay, thank you.
Anybody else having any question?
So the stack wise, there isn't any redundancy, right?
Stack wise?
If because everything is interconnected, what happens if one of the like server rack, one of the module goes down?
Okay, so they are connected in a circular fashion actually, like this. Okay, what happens is one of them becomes master, rest all become slave. So when you log in, you will always log into your master device. Okay, and within the master itself, if you check show interface brief or show interface status, it will list down all the ports. Let's say this is 24 port, 24 port, 24 port, 24 port. So all the 96 ports will be enlisted over here.
Okay.
Right. If one of the switch went away, another one will become automatically master.
Okay.
And since this switch has gone down, only the ports which will be affected or the devices which will be affected, which are directly connected onto this switch, which has gone down. Rest will remain up.
Okay.
Right. So guys, let's pause over here. Yeah, any question?
Yes, sir. Then this slave will become the master.
Correct. One of the slave will become the master.
Understood. And one more thing, sir. Yes, please.
Sorry, go ahead, Ashraf.
It's okay. It was different topic, so it would be better if you.
So all right, sir. The fourth different design criteria that is what I was asking, where we could still construct a 0.0.0.0 as the default gateway, where I would point to the D1 and D2 downlinks, both as the next hop for that 0.0, like that default gateway. That can also be one other design. I mean, one other design idea, right?
I could not understand.
No, instead of using HSRP or VSL or this stackwise, the fourth different design that we could still make it work is from the server. I could still connect. I could still do a default route.
Okay,
pointing to D1 and D2's downlink.
Wait a minute. Let me try to draw. You said D1, D2 connected to an access switch.
Right.
Then this is my server. Let's say this is having an IP address 10.10.
Right.
Now tell me.
Now D1 and D2 are L3 switches, right?
Okay, this link is L3 or L2?
That is L2.
That is L2. Okay. Now on D1,
so uplink of D1 and D2 are L3.
This one,
right?
L3.
Yeah, L3.
Okay.
The downlink being L2, I can't. I can still construct an SVI.
Okay, SVI you configured over here or here.
Right.
As VLAN 10.
VLAN 10.
Okay.
Now, can I configure a default route
Where
on
shall I configure
S1?
it? Okay.
On S1.
Pointing towards?
Pointing towards...
Is gateway or default route one and the same?
Correct.
Mm-hmm.
Yeah, pointing towards both of those SPIs on D1 and D2.
So on D1, D2, you are putting different IP address?
Different IP address, yes.
Okay. Let's put this one. So you are saying I should put two different gateways, right?
Two different gateways, yes.
Okay. Now what will happen? As long as first is available, I'll always be sending it to this one.
Want it ECMP, sir?
I don't think so. In, let's say, Windows PC, you configure primary and secondary.
Okay.
Isn't it?
Okay.
I don't think so. You can try this. I don't have Windows machine. You can try this thing. In a Windows machine, whether it is primary or secondary or same.
Okay, sounds good, sir. Thank you.
So let's take a pause today and check.
Yes, sir. One last thing I would like to ask.
Yeah, good.
Like,
good.
if you can just take 2 minutes and just explain, like, what and all changes you did in last 25 years of your career, like how you chose networking.
I started my career with networking itself. I mean, I worked as a L1 engineer, troubleshooting the things, making RJ45 cables, connecting them together, learn CCNA, CCNP, and then few CCIs I earned. And worked in NOC also, worked in then implementations, migrations, designing as an architect also.
Okay.
So that's how I do.
Okay, so to become an CCIE, how much time it took for you, sir? Like first CCIE.
First CCI, I mean, just few years back. I mean, 5 years back, I earned my CCI. I attempted earlier also, but I could not clear that. It took me a lot of time. Right, so guys, tomorrow I will not be able to take this class. I have some personal work, but next Saturday